Good day, Grade 7. Today, we are going to discuss Science 7, Quarter 4, Module 4, Atmospheric Phenomena. The content of this video is taken from the self-learning modules produced by the Learning Resource Management and Development System of the Schools Division of Bulacan. Objectives: account for the occurrence of land and sea breezes, monsoons, and intertropical convergence zone or ITCZ. At the end of this module, you are expected to 1. Explain what happens when air is heated. 2. Compare which warms up and cools faster, sand or water. 3. Discuss monsoon. And 4. Indicate the air movement at the equator. What I know. Choose the letter of the best answer. Write the letter of your choice on your answer sheet. See pages 2 to 3 of Quarter 4, Module 4. What's in? Part 1. Directions. Identify the following layers of the atmosphere. Choose your answer from the word bank. Number 1. This layer of the atmosphere merges into space. Satellites are stationed in this area 500 kilometers to 1,000 kilometers from the Earth. Answer: exosphere. Number 2. This layer of the atmosphere is between 80 kilometers and 110 kilometers above the Earth. Answer: thermosphere. Number 3. The layer between 50 kilometers and 80 kilometers above the Earth's surface. Answer: mesosphere. 4. This is the layer closest to the Earth's surface. The temperature just above the ground is hotter than the temperature high above. Answer: troposphere. And number 5, the layer of the atmosphere that extends to about 50 kilometers from the Earth's surface. Many jet aircraft fly here because it is very stable. Answer: stratosphere. Part 2, Directions. Use the diagram below to label the layers of the atmosphere. Choose your answer from the word bank above. So for number 1, the first layer of the Earth's atmosphere closest to the Earth's surface is the troposphere, followed by the stratosphere. Number 3, we have the mesosphere. The fourth layer of the atmosphere is the thermosphere. And the fifth and the outermost layer is the exosphere. What's new? Let's read a short paragraph. Mrs. Sofia Ventura, your science teacher, starts her lesson. Everyone is listening. You notice that all windows of the classroom are closed because of the strong wind outside. You've seen your classmates wiping sweat from their faces, and the temperature is getting high, and it will be difficult for them to understand the lesson. That's why you decided to open the windows, and everyone gets happy because the students are now comfortable while listening to Mrs. Sofia Ventura. Let us answer the following guide questions. Number 1. What are the possible things that might happen to your classmates once you open the windows? To your teacher? So, for number 1, the answer is they will feel more comfortable because of the cool air from outside. 2. What do you think will happen to the papers on the teacher's table once you open the window? So, answer: the strong wind will blow the papers on the teacher's table. And number 3, compare the temperature inside the classroom and outside the classroom. Answer: the temperature inside the classroom is high, outside it is low. Common atmospheric phenomena. In this module, you will learn concepts that will help you understand common atmospheric phenomena. The first is why the wind blows. Next, why monsoons occur. And the third, what is the so-called intertropical convergence zone. So all of these things that we have just mentioned are driven by the same thing, the heat of the sun or solar energy. Thus, we begin by asking, what happens when air is heated? What happens when air is heated? Objective: explain what happens when air is heated. Materials: 2 paper bags, candle, a long straight stick, match, masking tape, and a chair. Procedure: Number 1. Attach a paper bag to each end of the stick. The open end of each bag should be facing down. 2. Balance the stick with the paper bags on the chair. 3. Make a prediction. What do you think will happen if you place a lighted candle under the open end of one of the bags? 4. Now, light the candle and place it below one of the bags. Caution: do not place the candle too close to the paper bag. It may catch fire. Be ready with a pail of water or wet rag just in case. Question number 1. Was your prediction accurate? Describe what happened. And question 2. Can you explain why? So what happens when air is heated? The paper bag with a lighted candle below it rose. So how did this happen? Inside the paper bag are air molecules. When a lighted candle was placed below one of the paper bags, the air molecules started to expand because of the heat. The density of the air inside the paper bag became lesser, making it lighter. Thus, it rose. When the candle was removed, the paper bag sank because removing the source of heat made the air inside the paper bag to contract, making the density greater. Thus, the air became heavier. This is the first concept that you need to know: warm air rises. The idea that warm air rises is applicable to sky lanterns and hot air balloons. Heating the air inside the sky lantern and the hot air balloon will make the air inside less dense than the surrounding air. The result is the sky lanterns and the hot air balloon floats. Now, let us try to answer the following questions. When warm air is rising, what is its effect on the air in the surroundings? Next, will the air in the surroundings stay in place? Or will it be affected in some way by the rising air? Do the following activity to find out. What happens to the air in the surroundings as warm air rises? Objective: explain what happens to the air in the surroundings as warm air rises. Materials: box, scissors, cardboard tube, a clear plastic, candle, match, a smoke source. Example given: mosquito coil. Procedure: pre-activity, making of a convection box. Number 1, make 2 holes in the box. One hole on one side and another hole on top. 2. Place the cardboard tube over the hole on top and tape it in place. 3. Make a window at the front side of the box so you can see inside. And 4. Cover the window with clear plastic to make the box airtight. Figure number 4 shows our setup for the activity. We call this as a convection box. A convection box demonstrates the flow of convection currents in gases. Activity proper. 1. Open the box and place the candle directly below the hole on top. Light up the candle and close the box. 2. Make a prediction. What do you think will happen if you place a smoke source near the hole? 3. Now, place the smoke source near the hole. Question 1. Was your prediction accurate? Question 2. What happened? And question 3. Can you explain why? What makes the air move? Air in the surroundings can be affected by rising warm air. The drawing on the right shows how this happens. First, the air above the candle becomes warm because of the flame. What happens to this warm air? It rises. As warm air rises, what happens to the air in the surroundings? It will move toward the place where warm air is rising. But you cannot see air. How can you tell that it is moving? So did you see the smoke from the mosquito coil? The movement of the smoke shows the movement of air. Let us now relate what happened in the activity to what happens in nature. During the day, the surface of the earth becomes warm because of the sun. Some parts of the earth will warm up more quickly than others. Naturally, the air above warmer surfaces will also become warm. And what happens to the warm air? Just like in the activity, it will rise. How is the air in the surroundings affected? It will move towards the place where warm air is rising. So to further explain, let us take a look at this illustration. During the day, land surfaces warm up faster than the sea. So air above the land surfaces will become warm. And what happens to warm air? Warm air rises. Now, when warm air rises, it needs to be replaced. So where would the replacement come from? It would come from the surroundings. So air in the surroundings will move towards the place where warm air is rising to replace it. This is the other concept that you need to know. Air moves toward the place where warm air is rising. Whenever we feel the air moving, that means that somewhere warm air is rising. And the air around us moves toward the place where warm air is rising. Do you remember that moving air is called wind? Every time you feel the wind, it means that air is moving toward the place where warm air is rising. Strictly speaking, wind is air that is moving horizontally. So how does wind happen? So warm air rises into the atmosphere. Warm air cools, becoming denser. So when cool air becomes denser, it sinks, producing wind. Let us now use the two concepts you have learned to explain other things. You know that the surface of the earth is made basically of two things, land and water. When the sun's rays strike land and water, do they heat up as fast as each other? Do land and water absorb heat from the sun in the same way? Or is there a difference? Perform the next activity and find out. Which warms up faster? Objectives: 1. Compare which warms up faster, sand or water. 2. Compare which cools faster, sand or water. 3. Use the results of the activity to explain sea breeze and land breeze. What to use? 2 identical plastic containers, 2 thermometers, 2 iron stands with clamps, string, water, sand. What to do? In the shade, set up everything as shown below. The bulbs of the thermometer should be 2 centimeters below the surface of water and sand. So here we have 2 plastic containers of the same size. The first one is half filled with water. The second is half filled with sand. The thermometers are suspended using the iron stand with clamps. The bulbs of the thermometer should be 2 centimeters below the surface of the water and the surface of the sand. Number 2, wait for 5 minutes, then read the initial temperature of the water and sand. Record the temperature readings below. 3. Now, place the setup under the sun. Read the thermometers again and record the temperature readings in Table 1. Read every 5 minutes for 25 minutes. Number 4. After 25 minutes, bring the setup back to the shade. Read the thermometers and record the temperature readings in Table 2. Read every 5 minutes for 25 minutes. Picture 1 shows our two setups. The bulbs of the thermometer should be 2 cm below the surface of the water and sand. Picture 2 shows our two setups in the sand. It also shows students reading the thermometers and recording the temperature readings in Table 1 every 5 minutes for 25 minutes. Picture 3 shows our two setups in the shade. It also shows students reading the thermometers and recording the temperature readings in Table 2 every 5 minutes for 25 minutes. Here is the data gathered from the activity. Table 1 in the sun. Observation time in minutes, temperature of water and sand in degrees Celsius. The temperature of both water and sand was taken every 5 minutes for 25 minutes. The initial temperature for both water and sand is 28 degrees Celsius. So after 5 minutes, the temperature of water became 29. After 10 minutes, 29.5. After 15 minutes, 30.5. After 20 minutes, it became 31. And after 25 minutes, it became 32 degrees Celsius. For the sand, after 5 minutes, it became 29. After 10 minutes, 31.5. After 15 minutes, 33. After 20 minutes, 34.5. And after 25 minutes, it became 36 degrees Celsius. Next, table 2 in the shade. So the observation time is also in minutes. The temperature for both water and sand is in degrees Celsius. The temperature of water and sand in the shade was taken every 5 minutes for 25 minutes. So, the last reading is 32 degrees Celsius for water and 36 degrees Celsius for sand. So, after 5 minutes in the shade, the temperature of the water dropped to 31. After 10 minutes, still 31. After 15 minutes, 30.5. After 20 minutes, 30. And after 25 minutes, 30 degrees Celsius. For the sand, after 5 minutes, it dropped to 34 degrees Celsius. After 10 minutes, 32.5. After 15 minutes, 32. After 20 minutes, 31.5. And after 25 minutes, 31 degrees Celsius. Number 5, study the data in the tables and answer the following questions. Question 1, which has a higher temperature after 25 minutes in the sun? Water or sand? For question 1, the answer is sand, 36 degrees Celsius. So we could see here that after 25 minutes, the temperature of sand is higher than that of water. Q2, after 25 minutes, how many degrees Celsius was the increase in the temperature of the water, of the sand? So for Q2, the answer for the first question, so the increase in temperature of the water is by 4 degrees Celsius. So the initial temperature is 28 and the final temperature is 32. So subtract that, you get 4 degrees Celsius. For the sand, the increase in temperature is 8 degrees Celsius. So initial temperature is 28 degrees Celsius and then the final temperature for sand is 36. So subtract that, you get 8 degrees Celsius. Question 3. Based on the data, which became hot faster, water or sand? So answer, sand. Looking at table number 1, we could see that after 25 minutes, the temperature of the sand is higher than that of water. Next, question 4. What happened to the temperature of the water and sand when brought to the shade? Answer, both cooled down. Looking at table number 2, we could see that there is a decrease in the temperature of water and sand when they were brought into the shade. But sand cooled down faster than water. So let's go to question number 5. How many degrees Celsius was the decrease in temperature of the water after 25 minutes and of the sand? Answer, for the water, the decrease in temperature was only 2 degrees Celsius. So from 32 degrees Celsius, the final temperature in the shade was 30 degrees Celsius. So there was a 2 degrees Celsius drop in the temperature for water. For sand, the decrease in temperature is 5 degrees Celsius. So the initial temperature was 36. After 25 minutes in the shade, it became 31. So this is our proof that the sand cooled down faster than water. Sea breeze and land breeze. The sand and water in the activity stand for land and water in real life. From the activity, you have learned that sand heats up faster than water and that sand cools down faster than water. In the same way, when land surfaces are exposed to the sun during the day, they heat up faster than bodies of water. At night, when the sun has set, the land loses heat faster than bodies of water. How does this affect the air in the surroundings? Imagine that you are standing by the sea along the shore. During the day, the land heats up faster than the water in the sea. The air above the land will then become warm ahead of the air above the sea. You know what happens to warm air? It rises. So the warmer air above the land will rise. The air above the sea will then move in to replace the rising warm air. You will then feel this moving air as a light wind, a sea breeze. So to further explain this, let us take a look at our illustration. During the day, the land surfaces become warmer ahead of the water in the sea. So land heats up faster during the day. The air above the land will become warmer ahead of the air in the sea. So what will happen to the air above land? So the warm air rises. As warm air rises, it needs to be replaced. The replacement will come from the air above the sea. So the air blows from the sea to replace the rising warm air. So we call this moving air as a light wind, and we call it as a sea breeze, and it happens during daytime. What will happen at night when the sun is gone? The land and sea will both cool down, but the land will lose heat faster than the water in the sea. In other words, the sea will stay warm longer. This time, the air above the sea will be warmer than that above land. The warm air above the sea will then rise. Air from land will move out to replace the rising warm air. This moving air or wind from land is called a land breeze. So to further explain, let's take a look once again at our illustration. At night, when the sun has set, both land and sea will cool down. But land loses heat faster than the water in the sea at night. This means that the land is cooler, the sea stays warmer longer. So what happens next is the air above the sea is warmer than that of the air above land. So the warm air above the sea rises, and when this happens, it needs to be replaced, and the replacement will come in from the land. So air blows out to the sea to replace the rising warm air. So this wind from the land is what we call as a land breeze. And land breeze happens during nighttime. In the illustration, you can see an arrow pointing upward. This arrow pointing upward represents rising warm air. The place where warm air rises is a place where air pressure is low. In other words, the place where warm air is rising is a low pressure area or LPA. In contrast, cold air is dense or heavy and tends to sink. The place where cold air is sinking is a high pressure area or HPA. So, in this illustration, we could see that during the day, our low pressure area is above land because land is warmer than the water in the sea. So, above sea, we have a high pressure area. Next, at nighttime, the positions are reversed. Our low pressure area is found above the sea because the sea stays warmer longer then the land at night. So above land, we have a high pressure area. Next, based on what you have learned so far, in what direction does air move? So looking back at this illustration, we could see that the movement of air is from high pressure area going to a low pressure area. High pressure area going to a low pressure area. Monsoons. Many people think that monsoons are rains. They are not. Monsoons are giant breezes. Monsoons are wind systems resulting from temperature and pressure differences between continents and oceans. But these winds usually bring abundant rainfall to the country, and this is probably the reason why they have been mistaken for rains. In Filipino, the monsoons are called amihan or habagat depending on where the winds come from. What happens during the colder months? The wind blows from the high pressure area in the Asian continent toward the low pressure area south of the Philippines. The cold air that we experience from December to February is part of this wind system. This monsoon wind is locally known as amihan. The wind passes over some bodies of water before it reaches the Philippines. The wind picks up moisture along the way and brings rain to the eastern part of the Philippines. To further explain about hanging amihan, let us take a look at our illustration. During December, it is winter in the northern hemisphere. A high-pressure area develops above the Asian continent. In the southern hemisphere, it is summer. So a low-pressure area develops over areas to the south of the Philippines. In the previous slides, we have learned that air moves from high-pressure area to low-pressure area. That is why, during December, air moves from the Asian continent going to the south of the Philippines. As the wind moves, it picks up moisture from the bodies of water it passes, and it brings lots of rain to the eastern portion of the Philippines. Hanging amihan is also known as the northeast monsoon. It happens during the months of December to February. The wind is characterized as being cold and dry, and the northeast monsoon or hanging amihan causes much rainfall over the eastern coast of the Philippines. What happens during the warmer months? What do you observe about the low pressure area and high pressure area near the Philippines? They have changed places. As a result, the direction of the wind also changes. This time, the wind will move from the high pressure area in Australia to the low pressure area in the Asian continent. This monsoon wind is locally called habagat. To further explain about hanging habagat, let us take a look at our illustration. During the month of June, it is summer in the northern hemisphere, so a low pressure area develops above the Asian continent. In the southern hemisphere, it is winter. A high pressure area develops over areas to the south of the Philippines. So we have learned that air moves from high pressure area to low pressure area. That is why, during June, air will move from the south of the Philippines to the Asian continent. So hanging habagat is also known as the southwest monsoon, and it happens during the months of June to October. So hanging habagat brings lots of heat and water vapor as it passes over the Philippines. So it also brings continuous rains to the western parts of Luzon, Mindanao, Panay, Negros, and Palawan. So can you explain why the habagat brings so much rain? So looking back at our illustration, we could see that the hanging habagat passes over some large bodies of water. So as it passes these bodies of water, it picks up moisture and it brings lots of rain to the western part of the Philippines. So the part of the Philippines that the habagat affects the most is the western part of Luzon, Mindanao, Panay, Negros, and Palawan. Let us now compare southwest monsoon from northeast monsoon. The local name of southwest monsoon is Habagat. The origin is the southwestern part of the world. Characteristics: warm and humid. Effects: cumulus clouds and heavy rains. The northeast monsoon's local name is Amihan. Origin is the northeastern part of the world. Characteristics: cold and dry. Effects: cirrus clouds, light rains, and cold weather. The monsoons, Habagat and Amihan, affect people in different ways. Try to explain the following. Number 1. Why do farmers welcome the monsoons? 2. Why are fisher folk not so happy about the monsoons? 3. Why do energy providers appreciate the monsoons? 4. Why are fish pen owners worried about the monsoons? And 5. How do monsoons affect your own town? Intertropical convergence zone. Many people who listen to weather forecasts are confused about the intertropical convergence zone. But it is easy to understand it once you know that warm air rises and air moves toward the place where warm air is rising. Take a look at the drawing. The drawing shows the rays of the sun at two different places at noon. Study the drawing carefully. Where would you observe the sun directly above you? When you are at the equator or when you are at a higher latitude? As you can see, the position of the sun at midday depends on where you are. At the equator, the sun will be directly overhead and the rays of the sun will hit the ground directly. At higher latitude, the sun will be lower in the sky and the sun's rays will strike the ground at a lower angle. Let's take a look at our illustration. The rays of the sun will hit the equator directly. The angle formed by the rays of the sun is 90 degrees. Direct rays means that the surface will be hotter. Next, the rays of the sun will strike the ground at a lower angle at higher latitudes. The rays of the sun are oblique at higher latitude. Oblique rays means that the surface will not be as hot as the surface on the equator. Where do you think will it be warmer? It is warmer at the equator than anywhere else. The air over the equator will be warmer than the air over other parts of the earth. So what happens to warm air? So we have learned from the previous lessons that it rises. And when warm air rises, air in the surroundings will then move as a result. In this figure, we could see that it is warmer at the equator than anywhere else. And the air over the equator will be warmer than the air over other parts of the earth. So what will happen to warm air? Warm air rises. And as warm air rises, it needs to be replaced. So, air from north of the equator and air from south of the equator will move toward the place where warm air is rising. The intertropical convergence zone is the place where winds in the tropics meet or converge. In time, the rising warm air will form clouds, which may lead to thunderstorms. Weather forecasters often blame the ITCZ for some heavy afternoon rains. The band of white clouds in the picture shows the location of the intertropical convergence zone. Let us now discuss the different activities in What's More. Independent Activity 1. Put an arrow inside the box to indicate the direction of the air. Complete the flow chart. So the flow chart is about land breeze and sea breeze. Independent Assessment 1. Read the following statements carefully. Place your answer in the corresponding table below. If the statement refers to land breeze, place your answer in the first column. If the statement refers to sea breeze, place your answer in the second column. Independent Activity 2, Who am I? Part 1, identify the following statements whether it is a land breeze or sea breeze. Part 2, fill each column with the correct answer. So the second column is about land breeze. The third column is about sea breeze. You're going to write the time they are formed and the wind direction. Choose from the word bank. Independent Assessment 2, Part 1, write P if the statement is true and write F if otherwise. Part 2, fill each blank with the correct answer. Northeast monsoon, southwest monsoon. What, when, and where? Independent Activity 3, multiple choice. Read carefully the questions and choose the correct answer. Write the letter of the correct answer on your answer sheet. Independent Assessment 3, Part 1, fill in the blanks with the missing letters to complete the word described by the clues. Part 2, look at the figure below and answer the questions. Where would you observe the sun to hit you directly? At the equator or when you are at higher latitude? So for Independent Assessment 3, you will be graded based on this essay writing rubric. Content, 10 points. Spelling and grammar, 5 points. Structure, 5 points for a total of 20 points. What I have learned. Let us now summarize the lesson by completing the paragraph below with the correct terms. What I can do. This is it. The day has arrived for your family's vacation at Boracay Beach. Every family member is excited. Your parents have been planning this. Now, let us relate our topic to your dream vacation. How do land breeze and sea breeze, monsoons, and intertropical convergence zone affect your Boracay escapade? You might answer it by illustrating and providing a brief explanation. Use the box below. For what I can do, you will be graded based on the scientific drawing rubric. Creative process, 5 points. Neatness, 5 points. Understanding content, 5 points. Explanation, 5 points for a total of 20 points. Assessment. Choose the letter of the best answer. Write your answer on your answer sheet. See pages 19 to 21 of Quarter 4, Module 4. Additional activity, performance task number 4.4. Give the correct word that corresponds to the jumbled letter. Science 7, Quarter 4, Module 4, Atmospheric Phenomena. Answer the following on your answer sheet. What I know, what's more, answer independent activities 1, 2, 3, independent assessments 1, 2, 3, what I have learned, what I can do, assessment, and additional activities. The additional activities will be your performance task number 4.4. Upload your answer sheets in PDF format in your Google Drive folder. The path is Science 7, Quarter 4, Module 4. Or send them in JPEG format to my messenger. Thank you for attending our Science 7 online class. God bless you all.